This is the second regression example. We're going to do hospital beds. Recall that the correlation between the licensed beds and the number of staff beds was 0.91. Very ugly handwriting. So first we're going to find the slope. Let's be 1. We need the standard deviation for y and the standard deviation for x. So it's going to be 1.47 divided by, from here, 0.89 times the correlation. And this piece is going to be 1.65 times 0.91. It comes out to 1.5. There you go. So that's our slope. Let's find the y-intercept. So B0 is going to be 4.17, that's our y-bar, minus what we just found, times 2, basically. This value and this value is what we're using. So let's do this piece first. 4.17 minus, that's just 3, B0. So 1.17. That is our y-intercept. So next we just have to find our regression equation. And this is just creating the equation, like putting the pieces together. Plus 1.5. And then you could put x, or you can put whatever x is, which in this case is licensed hospital beds. The other way you could write this would be staffed beds, which is our y. We would put like a giant hat on it. 1.17 plus 1.5 licensed hospital beds. Do not have enough space here. So the next thing is actually to find that prediction. So y hat is going to be 1.17 plus 1.5. In this case, we wanted to see what the prediction is going to be when we have 2 licensed hospital beds. So that is plus 3. .17. Well, that's an interesting number. So now let's talk about the output. So here we have our correlation. Remember, Jamovi, if this was negative, Jamovi will not put the negative there. So it's always better that you find the correlation through the correlation menu, or you can calculate it yourself, or just keep in mind this is the absolute value. So you need to check. The r square is just the r, square. Let me redo that. So it's just 0.911 square, which is 0.83%. So what we're doing in regression is we have a y and we have an x, and x is the number of licensed hospital beds. Well, y is going to be the number of staffed beds. And we're trying to predict that. So 83%, like we would multiply this by 100, 83% of the variability in y in the staffed beds is explained by the number of licensed hospital beds. We also have another I was going to say menu, but it's a table, model coefficient. So this one is going to have the y-intercept, and that's exactly what we got. This is our B0, and this is our B1. Hospital beds is 150. That's exactly what we got. And we also are going to need the p-value here. This p-value, we're going to compare it to an alpha of 0.05. And we know it's smaller, so it is statistically significant. Recall the null and alternative hypothesis for regression. So we reject this one, reject the null hypothesis. So there is statistically significant linear relationship between the number of staff beds and the number of licensed hospital beds. Okay, so let's go over the conclusions. So simple, you need to give the name, simple linear regression. There's different types of regression. This is the one we're doing right now. You need to give the alpha, especially if you're going to talk about statistical significance. The number of licensed hospital beds, so this is our X. Was a statistically significant predictor. How do I know? I know from here, because our p-value is less than alpha, of the number of staff beds. So this is actually our Y or dependent variable. This one would be our independent variable. Beta, I get from here. Well, the p-value, I get it from here. The R-square, we got all the way from the very first table. So that's what the R-square was. We multiplied by 100 to get the percentage. And that's how much variance explains. Over here we have our prediction. And that's what we found in our prediction. So I'm going to be honest, this part, it's mostly for teaching purposes. In practice, we don't do that.